Wanted to talk about the rare earth metals, and that on the periodic table, if you look at the bottom left, there's a slot where there's a space for atomic numbers 57 through 71 inclusive, and it's usually broken out toward the bottom of the periodic table because all of those elements on that top row of that bottom left to right portion of the periodic table are called the lanthanide series. Below that is the actinide series, which are all radioactive material, which we'll save that for another day. But the lanthanides are rare earth metals. Those have become more important in recent years with the advent of batteries and gadgets, electronics, touchscreen glass, and eco-friendly building materials. They're more and more ever present, but are increasingly rare. Now, rare is a relative term. The Earth's crust has them consistently throughout the planet, but they're only not in sufficient concentration to be mined profitably. So there are certain points in the globe where these elements are in sufficient concentration for mining. Sometimes those locations are inhospitable or politically unstable, and thus the challenge for the future of the rare metal mining industry. It's heavily technical, heavily economically intensive, environmentally challenging, and there's really not a specific playbook for mining, for accessing these minerals and ores, processing them, crushing them, soaking them in acids, spinning them, flocculating them, moving out impurities in a flock that flowed out of a concentration. They're highly protected by patents, both the United States and otherwise, and national security. Governments protect this data, and each element and each mine has a different chemistry to it. So there's, again, really not a specific means or a cookbook for getting these materials mined. More about that later. Just wanted to share some of the research I've been going through. I think this is a really fascinating topic I'd like to write about more and talk about more, the rare earth metals.